Hello there. In this video, we explain the solution to the homework exercise 5 about the Collatz sequence. The problem is on the left, but I'll focus on the code solution on the right. Our first task is to create a function called Collatz next, which finds the next number in the Collatz sequence starting from any given number. So in terms of syntax, I name my function whatever I want. In this case, I name it Collatz next. I tell R, okay, this is an object of type function. So I, in some sense, allocate to Collatz next a function. Now the function will be defined inside the curly brackets that are opened here and closed here. So this line is for ending the function. Now this function has only one argument here called x, and x here simply represents the number from which I want to get the next number in the sequence. By default, I'm setting this argument to be 1. So this is what equals 1 means. It's the default value of x. If the user uses the function without specifying x, well, x will be assumed to be 1. This is what the default argument means. Now, the algorithm we need to implement is given here on the left. If this number is 1, well, we stop the algorithm and we return 1 simply. So this is what the first statement is doing. If x equals 1, open curly brackets, close them here, we return 1. And this actually terminates the function in the sense that whenever return is called, everything after is not executed. So we would simply return 1, and that's it. However, if x is not 1, then the code will go here, meaning R will read the next line of code, which is the second possibility that x is even. So here we have a logical statement checking if x is even. Indeed, the percentage sign means the remainder of a division, meaning when I divide x by 2, what's the remainder? If this thing equals 0, well, then you know that x is even. Of course, any even number divided by 2 will have no remainder. If I divide odd number by 2, well, the remainder will be 1. But so if x is even, meaning if this thing is 0, return whatever the algorithm tells us, which is x divided by 2. So return x divided by 2. That's the second case, and we only have a third case. So else, meaning if this is false, then do whatever is inside the else statement opened here and closed here. Else return 3 times x plus 1. Indeed, we need to multiply the number x by 3 and add 1. And we're done. That's we have treated every single case. X equals 1, x is even, or x is anything else, any other odd number. And then, of course, we end the function, and here we can simply test it. So you can try to see for yourself what should be the next number after 9 in the sequence. Well, it's an odd number, so we need to multiply by 3 and add 1. So let's run the function. We get 28. Sorry, this is the code for the next function, which is finding the entire sequence, which we will review now. So the second task was to create a function that not only gives you the next number, but in fact gives you the entire sequence until you get to 1. So in fact, the fact I've executed it already allows me to illustrate what we want. So this is the result we want. From 9, we need to continue the sequence, which is always divide an even number by 2, and then multiply an odd number by 3 and add 1. So from 7, for example, you get to 22. So keep doing that until you get to 1, until you get to a termination of the sequence. So now we present a solution of how to create such a function. Again, we call our function whatever we like. In this case, we call it Collatz sequence. We declare it to be a function with, again, only one argument, which in this case, the argument is where do we start the sequence that we eventually want to terminate at 1. And once again, the goal is to return the entire sequence from that number we input, the x, until we get to a 1. Now, because we want to keep a memory of all the numbers in the sequence, we will declare an object called mySequence. And conceptually, what we do is we simply iterate, and we will add to mySequence whatever number is next, And we'll keep doing that until we get to a 1, because once we get to a 1, we're done. We have the entire sequence. How can we do that? How can we keep doing an operation until a condition is satisfied? Well, you guessed it, is with the while statement. While does exactly what we want. While something is true, keep going. So in our case, while the last number in the sequence is not 1, we need to keep going. If it's 1, then we terminate. And now I said that a bit quickly. This command here, tail my sequence 1, gives us exactly the last number in the sequence. Yes, because tail gives you the last few numbers, but if you say, okay, tail of only one element, it's going to grab the absolute last element in whatever sequence you have. Well, in a vector, but in this case, the vector is called my sequence, my sec, I should say. So again, while the last number in the sequence is not 1, then execute whatever is here. And whatever is here is simple. Find the next number in the sequence, because we keep growing the sequence until we finish, until we find a 1. So the next number, I call this a variable called next NB. The next number can be found using my old friend, the function Collatz next that I had declared here. So Collatz next of the last number in the sequence is what I want. It gives me the number after that. So the number after the last one that I had becomes my next number. And then I can add this new number. So for example, after 9, I would find 28. So I can add the 28 to the sequence that was composed of the number 9. How do I do that? Well, I simply update. So careful here, I update my vector, my sec, to be the one before. So vector, C is to create a vector. So C of my old vector, my sec, but then I add to it, it will be the last number in the vector. I add to it what is now the next number. So again, to 9, I add 28, but after that, from the vector 9, 28, I will add 14. And from the vector 9, 28, 14, I will add 7, and so on. That's it. I close here my while loop, which again will execute until I get a 1. And indeed, once I get a 1, I finish. The last step in my function is then to return the entire vector, the entire object, my sec, because again, it will contain everything. We're pretty much done. I've already tested here. I can do it again. I'm gonna test that it works. Maybe we can try it with a different number. Let's say the one given in the example or the statement of the question on the left. Let's say Collatz sequence 5. That's a short one. From 5, I go to 16, to 8, to 4, to 2, to 1, and I terminate. Good. It looks like everything is working. Thank you for your attention.